In this question, we have a skier who is going down a hill. This hill is at a 45-degree angle, and the skier starts down it with a velocity of 20 meters per second. We are told that 10 seconds later, the skier reaches a jump, which is 5 meters tall and at an angle of 20 degrees. And we want to know what was their velocity as they launched off the jump. Now, this is a motion on an inclined plane question. So we know the acceleration is equal to plus or minus g sine theta. But in this case, we have two inclines. We have the hill and we have the jump. Let's start with the hill. We know the skier's initial velocity on the hill is 20 meters per second. And we were told that the skier goes down the hill for 10 seconds. And we can also figure out the skier's acceleration. We just have to plug in our values for g and the angle of the incline, and we find that the acceleration is equal to about 6.9 meters per second squared. And I knew this answer should be positive because an object going down an inclined plane speeds up. And that means the acceleration vector has to be in the same direction as the velocity vector, so it would be to the right and positive. Now let's look at the jump. We can also find the skier's acceleration as they're going up the jump. All I have to do is plug in my values, and we find that the acceleration is equal to negative 3.4 meters per second squared. Now I knew this acceleration would be negative because objects going up an inclined plane are slowing down, and that means the acceleration vector is in the opposite direction of the velocity vector. So in this case, it would be to the left, and it would be negative. Now, in order to answer this question, we need the skier's initial velocity as they start at the jump. And this velocity would be equal to the final velocity that the skier has when they reach the bottom of the hill. So we will solve for the final velocity of the hill to get the initial velocity of the jump. To do this, we can use the Vf is equal to Vi plus A delta t kinematic equation. All we have to do is plug in our values and solve for Vf. And we find that Vf is equal to 89 meters per second. Now that we have the acceleration and the initial velocity, and we want to solve for the final velocity, we know we should use the Vf squared is equal to Vi squared plus 2A delta x kinematic equation. We have Vi, we have A, but we're missing delta x. So what we need to do is use trigonometry. We have the angle and we have the opposite side, and we want to solve for the hypotenuse. So we will use sine theta is equal to opposite over hypotenuse. We will rearrange for the hypotenuse, plug in our values, and we find that delta x is equal to about 14.6 meters. With that, we can use our Vf squared is equal to Vi squared plus 2A delta x equation. We can plug in our values and solve for Vf, and what we find is that the final velocity as the skier launches off the jump is about 88 meters per second. And that's the end of this motion on an inclined plane question.